Hi friends, welcome to this channel. Here we are going to look at problem 4008, minimum initial strength to defeat all monsters. I like this problem very much in the following sense. It can be used to practice the idea of line sweep and also practicing the binary search idea. First, let's look at the problem statement. I guess digesting the problem statement in every leetcode practice is very important, right? So here we are given an integer array called monsters, where each element represents the strings of the monster at that index. So we are also given a 2D integer array called boosts, where boost I is given a closed range from left to right with a bonus v, right? So it means that during this range, a boost is added while fighting any monster, right? So the boost range may overlap. That's a very important assumption, right? And the values of all applicable boosts are added together, right? So this paragraph actually tells us that we need a way to count the overall boosts. Right? So here we start with a non-negative initial strength and fight the monster from left to right. So for each monster at index I, so let boost be the sum of the value of all boosts that apply to monster I. So here we can defeat the monster only if our current strength plus the bonus is at least monster I, right? So after defeating the monster, only your current strength decreased by monster I. If it becomes a negative, it's set to be 0. In other words, the bonus is just to help you decide if you can beat the boosts or not. And then the resulted strength will be decremented by this one or set to be 0. So we want to return the minimum initial strength required to defeat all the monsters. So here from this one, we can think of this. So this basically gives us the hint of using binary search because of monotonicity hidden here. The reason is that if initially have a very large strength, for sure I can beat all the monsters. For example, the strength is larger than or equal to the sum of the monsters array, right? So our main goal is to, find the minimum strength required to defeat all the monsters, right? This is an emphasis what we just mentioned, right? The bonus is not added to our strength, but just determine if we can beat a monster. So if you look at example 1, so here is 30, right? So because in the first one is boosted by 10, right? So this is the explanation. So you have 30, so after the first one, at the index 0, you get 25. And then because 25 plus 10 for sure is greater than this one. So you have 25 minus 10 is 15. And then 15 is greater than or equal to this one, you can defeat. But afterwards, you get 0 strength. That's example 1. For example 2, here you have range 1 to 2. So this added 10, and the 1 to 2 added 5. So total is adding 15, right? So you can start from 5. So from 5, so you get 0. So then you get, after you defeat this one, you get strength 0. But here, your strength 0 plus the overall bonus 15 is greater than 10, you can beat this one. So then, because you have strength 0 minus 10 is negative 10, you set to be 0 for your strength. And then with the strength 0, you are looking at this one, but you have a bonus that is 15, right? You still can beat this one. So afterwards, you still get final 0 for strength. So with that said, first, so the steps will be the strategy, or it being to how to count the bonus accumulation at each and every indices, right? because it's a range count, so we can use less flip. I'm going to write the code and then use this example 2 to demonstrate that. So let sweep has a wide application. So a lot of problem in LeetCode, you can use this let sweep idea. So the second step will be binary search. So for binary search, typically you have two steps. One is to define a Boolean function. The Boolean function basically yields monotonicity, or in plain language, yields order. And then you are going to do search range shrinkage and return. So let me first do step 1, get the bonus count accumulation. So let me get this monsters, and then what I'm going to do is going to bonus. Let's use up. So from 0. So here I'm going to use a length n+1. Then what I'm going to do is that iterate over the boost for L, R, and boost in boosts. So starting from index L, so we are going to begin to increment by the boost. So it's increment. So after this R, so we are going to decrement that. So up. So here I write R plus 1. So I'm going to use minus equals boost. So this one, if we use prefix sum, so starting from L, you add boost. Then after this range out of R, so you're going to minus, right? So you can think of this procedure as a jump function, right? So the overall effect, if you do cumulative sum, it's like for I in range 1 n+1. So what you do is up I is incremented by up I minus 1. So because this for loop loops over all the range and the corresponding strings of boost, so this accumulation will count the effect of all the boosts at every index. So you can print out that. So so for this one, from index 0, 0 you should get 0, and at 1 and 2 you get 15, and then the last index is 0. So this is the first example, right? And for the second example, you should get 0, 15, and 15, right? So once you get this, so we're almost ready to write do binary search, right? Binary search. So first, I'm going to define a Boolean function. So for this, actually we reduce the problem to fat the mean such that if given the power, if you can finish all the tasks, is true. So next, I'm going to write the function called can we finish using this power at the very beginning, right? So this is very easy, right? So basically for I and monster in enumerate monsters, right? So if the power plus this given bonus is less than the monster power, so we cannot finish if it's this initial power. We just return false. Otherwise, so your power will be reset to be this one. Roughly, in general, it should be this power minus this monster power. But this can be negative due to the help of the boost. So what we want to return is max 0 and this value. So you can think of this just translate this text statement. So if after the for loop nothing has returned, you return true. It means starting from this power, you can finish right? Beat all the monsters. So the problem reduces to find the mean power such that this function is true, right? So this will be the minimal initial strength, right? So now let's do the search range shrinkage and search. So what we are going to do is we have a low and a high. So the lowest is 0, and the highest is just the monsters sum, right? So this for sure can be can be true. So you can say add 1 and choose a large enough line, but this just is sufficient. So what we are going to do? We are going to low is less than high. So I'm going to do shrinkage like this. Mid will be, so I'm going to add half from the bottom. So basically high minus low into the division by 2, right? Then I'm going to check if mid is true. In other words, if I use mid as power or strength, we can beat all the monsters. So in this case, we can lower the high to be mid. Notice that high is always making the scan finish right. Otherwise, so this mid is too small, I cannot finish. So the low should be at least a mid plus 1. So this way, for this condition, it will going to violate. So you're going to get low equals high, right? So this you can return low, you can return high. Both are okay. Let me track here. Yeah, it passes the 2 cases. Now let's look at generic case. Now it passes all the cases. Now let's return high. Yeah, that's awesome. So in general, so you can return high for this one. So with that said, I guess that's it for the current problem. So here I think a certain level of abstraction is important for us. So here we have 2 abstractions or 2 prototypes. One is landscape idea and the other is the general binary search idea, right? So these 2 ideas can be applied to all kinds of problems across LeetCode or daily coding. So it's good to practice more to really master it. With that said, that's it for the current video. Thank you for watching.